Hello everyone, welcome to my lecture series on the system Verilog deep dive assertions. So in this topic today we are going to discuss on operator sequences and properties. We are going to discuss more about on this topic. So I hope everybody like my video on my previous lecture, and this lecture we are going to deep dive more. So these are some of the introduction topics which we discussed in our previous lecture as well. So the rules of the hardware behavior as an assertion and the simulation, the verification, how it is going to use for, and how it will detect the protocol violations, all those things. And the assertions are embedded into the hardware verification. They are Let us describe expected behavior and catch bugs automatically in both simulation and the formal verification as well. And some assertions complement your judgments. So instead of manually checking waveforms, assertion point out exactly where the violation occurred. So it's saving the valuable of time. The human, the value is of the time is very important. So as we discussed in our previous lecture, there are two types of assertions. One is immediate, one is concurrent. So immediate is like a simple assertion, and the concurrent is a multi-cycle behavior assertion, which is I think more in common. And in the concurrent assertion, it has a structure, and they have a property, clock event, antecedent, consequent, and also an actual assertion. Together, they describe as temporal behavior. So these are some of the key operators available here, like incubation operator, cycle delay, and the repetitions between m and m times. So these are some of the foundations of the SVA coding. So these are the things which we use most of the times in this SVA coding. So system Verilog assertion based coding, and there are some of the operators this as well for the logical combination, and disable it for the reset handling function, and within to write the occurrences within the window. So these are some of the behind the basics, and these increase the flexibility of the writing a code in NSPA. That will be the great thing, the key operators. And coming to the sequences, these are reusable blocks of temporal logic. Instead of writing the same logic multiple times, we will capture once and we will reuse in the multiple properties. So those are called sequences. Coming to the properties, so a property combines conditions and sequences into a single rule. So assertions apply these properties to verify the correctness. So if you remember our handshaking protocol, at here the grant follows the request by one cycle. So this handshake protocol ensures the always is followed by the grant one cycle later. A common example in our bus protocols. So this will be like a property because it has a condition and a sequence, both of them. The condition is request is followed by grant, and it is going to call a property handshake. So that's how the condition and the sequence is monitored. So it is called a property. The same thing here as well. So for the FIFO, it prevents the FIFO going to be full or full dimensions. So both can never true on the same time. This is an unforced mutual exclusion. So one only come at the one other time. So in the backward pass, if you remember in my last slide also I discussed, suppose the wreck is never going to happen, the time the problem might be happen for the correctness. Sometimes the wreck cannot be happen every time. So the time assertions can pass recklessly when they trigger never occur. This is dangerous because it hides the untested condition of the other way. And we have are some cover properties as well. It will helps distinguish on real pass and quiz pass. So the cover properties make sure the event and the actual exercise. This way we avoid a false things. So cover groups and cover properties are important. So nothing but the coverages is important in order to do this. There are some advantages of SPA as well, as we discussed in previous slides as well. So it improves the verification efficiency, and also it has a the document intent, and also helps in the simulation and the formal verification as well. And in conclusion, as we discussed earlier, the DV mastering the SPA properties, sequence, and the properties, which will be stronger verification engineering when you use the cover properties to avoid the backwards passes and integrate SPA into your UVM flows. That's all for today, guys. So this video might be helpful in the attachment to my previous video.